Alright, this is video number... Wait a minute. Welcome back. This is workflow component number 2, Grasshopper import, scaling, and file linking. So we're going to be working pretty closely in Grasshopper today. There will be some kind of reference to the DEM we looked at in the last video for things like dimensions and scaling. But generally, we're going to be working in Grasshopper. So I'll sort of take you through the script. First, we'll look at what everything does, kind of with the broad strokes. This is not going to be a comprehensive walkthrough on how to make this script. Rather, I want this to kind of serve as just a video documentation so that you know how to use it and what to supply it with to get the best results. And yeah, then we'll sort of go through and run it, and then in video 3 we'll just play with it. Yeah, so hopping right in, I have it organized into technically 4 steps if you count step 0, but step 0 is just setting the world units to feet. That's sort of going to be our base unit that we're working in. So for starters, I'll just talk a bit theoretically about what we're doing. We're essentially going to take a flat plane, the ground, we're going to chop it up into a bunch of points, and then we're going to assign heights to the points based on where they are on the ground and where they are in our DEM, if that makes sense. It'll make more sense once we do it. But I'll just very briefly take you through. So first you create a plane. This plane is essentially your canvas that you're going to be projecting everything onto. And the X size and Y size, those are determined in miles. They're going to end up being the size of whatever image you have in GIS. Then you have this, which chops it up into all those points. I have it set to cut it up into 96 points in each direction. You can set that to whatever you want. The fewer the points, the faster it is, but the kind of uglier your mesh will end up being, the lower resolution, I should say. So then it's going to take all those points that it got, your 96 by 96 grid. It's going to preserve the X and the Y components. So basically, where on the canvas the points are. But it will get the Z component, which is how high each point is, based on the brightness of your DEM. So I have an old DEM in here right now. We're not going to use this one. We're going to use one that's a little more dramatic. But yeah, so essentially your DEM gets sampled. So each point is assigned a value that corresponds to a pixel in this image. And that value is the brightness of said pixel from 0 to 1. That value is then scaled by the total range of your elevation as listed in your DEM, so that it's dimensionally accurate with real life. That result is then reassembled. So those augmented Z coordinates are recombined with your X and Y coordinates to create a new set of points that follows the real-world geometry, and then you just have some basic construction. You have a point cloud, it builds a point cloud, some contour lines, and of course your mesh that it does using Delaunay triangulation. And then there's some basic transformation stuff that transforms the center of the geometry to the world origin, and a vertical exaggeration generator. So if you want to accentuate your topography at all, you can do that very easily. And then you just have the final output for baking here. So click bake, right click it, and then click bake, and you'll get actual manipulatable, transformable Rhino geometry. So I'm now going to go back and we're going to kind of go through the things that you, the user, have to supply. So we'll start with the x dimension of the raster in miles and the y dimension of the raster in miles. So these are very easily obtained. You just go back into GIS and go to map, and you can just measure it yourself. There are better ways and more precise ways to do this, but for our purposes, this will suffice. So we'll find the x dimension first. Our x dimension is going to be 48.3, and then we'll find our y dimension, and that's going to end up being 69.3. So 48.3 by 69.3, these down here. Ignore these values up top, these are from an earlier thing I was doing. So we'll take 48.3, copy that. We'll pop back over to Grasshopper and plug that in as our x value. Check. And then we'll go back to GIS. Go to our 69.3. Copy that. Pop over to Grasshopper. Plug that in as our y value. It is important to note that these x and y values are measured in miles. That is simply to minimize the number of decimal points you're working with. They're then multiplied by 5,280 to get the number in feet, which is our working unit, as I mentioned. And then the other thing you need to supply is the elevation difference. This is how you scale your z values to their true-to-life values. When they come out of the image sampler, they come out as values from 0 to 1, where 0 is black and 1 is white. And so you want to just expand that range so that they match up with how they do IRL. So to do that, we're going to go back into our GIS, and you can take your maximum and your minimum. I'm going to pull up my calculator here. We'll take our maximum, which is going to be 4391.98 minus 263.226 equals 4128.754. So this is the elevation range. This is the number that we want to scale our z values by. So I'm going to copy that, pop back over to Grasshopper, paste it, get rid of the comma. Grasshopper doesn't take commas. Click check. And now we should have what we want. I'm going to preview it in the point cloud first. We've got some nice elevation stuff going on, you can already tell. Wait a little bit, I'll go back to shaded mode, we'll be able to see better. Aha, there you go. Oh, whoops. I forgot to actually change the DEM, the image sampler. So to do that, you double click and you click these three dots here, and you can select from there. Let's see if I can actually find the file. Hang on. Okay, so the file's loaded, uh, and you can see obviously it's changed. Um, so before we had something that didn't look so great, and that's because we were using the wrong elevation value uh, with the wrong DEM. So now we're using the right elevation value and the right DEM. So when I close this, it should give us, oh, it's going to take a minute to update. There we go. It should give us something really cool. So I'll go back to those points, and you can kind of see here our point cloud. We've got something going on, and then go to our mesh, and you can pretty clearly see that here's peak number 1, here's peak number 2, and this one's Mount Rainier, I think. And then you go over to here. Here's your bright spot. So this has succeeded. This is the whatever your geospatial representation of Mount Rainier's topography. It's not actually that impressive when you're working at such a large scale, but yeah, it's actually quite tall. Um, that is sort of the drawback to working at this scale, is you will lose that sense of perspective quite easily, to where something very, very big looks quite small. We can look at our contours. Oof, those are 10-foot contours. We cannot do 10-foot contours on Mount Rainier. We can probably do 100-foot contours, and it'll still give us quite a few. But you can see you have one peak here. You have one peak here. These really need to be smoothed after you get them out of Grasshopper, but I leave that to you. Different people like to smooth them in different ways. Yeah. So then that'll all get transformed back to the world origin, and then we can, I'm going to switch this just to mesh. We can, of course, vertically exaggerate it up to 10 times. That's pretty dramatic. That's, if you were going to 3D print it, I would recommend a vertical exaggeration of some kind on anything at this scale. Maybe 5 times. That's pretty illustrative without being gratuitous, or maybe even 2 times. 2 times is still pretty crazy. We'll leave it at 1. And then you can right-click this, bake it to your default layer, and let's change this to maybe not Arctic. Let's try monochrome. Nothing really works. That's okay. It's a little tricky to kind of comprehend at this scale, but you know, if I type in the create a bounding box here, and I'll make our command line a little bit bigger, hopefully, so we can actually see the dimensions are, you know, pretty crazy. So yeah, that is more or less how you do it, or I should say how you use the script to just get an elevation representation. I suppose in the next video I'll show how to sort of incorporate the drawing, because this one feels like it's probably getting a bit long. So yeah, see you in the next one. We'll crack open my favorite open source drawing program, and we'll get cracking. We'll flatten all these here mountains. It'll be really funny. Anyways, yeah, see you then.